All right, so I realized I don't have any natural aspiration nitrogen filter tech for engines on my YouTube channel yet, but I kind of figured it'd be kind of simple to do. Just because it's like, well, it's sort of simplistic. Um, you really only need to make sure that whatever's lined on the inside isn't of any of your tubes that you're using isn't going to be something that's going to get corroded away by high oxidation occurrence, levels of oxidation. So, what that turns into is usually it's a fiberglass and epoxy, which is typically good enough, or a blend of quartz crystals inside of a 3D printed, uh, filament, which then means you can use silicone gasket material that will still oxidize, but I mean, they all oxidize over time. Anyways, you do need to cool these a little, but that's also kind of not true. Um, just because you're not going to be pushing pressure through it. They have high flow nitrogen filters that I found online, and my last video about this actually went over one of them, and they work up to 60 degrees Celsius. So, effectively, as long as it's within, the area of airflow, you're good. Then it just needs to have a pass through for the nitrogen to go off into the exhaust, which is like a blow off valve kind of thing. uh, the filtered higher oxygen, which is like a something like 99% efficient or something. So you have a very, very high oxygen content, the- which is great. Okay. Valves are kind of my main concern. Okay. Uh, Valves will corrode and oxidize. So you need to coat them with a powder coat. You need to powder coat also the inside of your ports, and the gasket materials you're going to want to use for the intake are going to need to be silicon and high temperature silicon, or silicone and multi-layer steel or some steel gasket. Aluminum likes to corrode a little bit better, um, but effectively oxidizes faster with aluminum when it's under that heat because the heat transfer. And so it'll corrode a little bit around where that is in the intake, and then it'll work its way around throughout all of it. But if you have steel, steel likes to expand, and when it's around silicone, high temperature silicone gasket material, it will sort of absorb into it and still keep it sealed, but you do have to check it every so often. But so long as you're able to powder coat most of the inside with a basic, like, meaning hell, my dumb ass goes to, I'll just epoxy it. I'm not even kidding. Like, I'm just gonna get some fucking epoxy. Like, epoxy is easy. Like, you know what I mean? Like, powder coat's like, I want it to look nice and stuff, versus slather in some epoxy here. And this will just and smooth it just a little, and then you can get the little heat shine up and get the buffer wheel. Ooh, oh yeah, no, I swear, it's the same as his thousand whatever powder coat. Goddamn. Yeah, it's the same. It's the same. Yeah, the same. It's not, but like, still, uh, the best I can do in terms of like just get it done for natural aspiration is just epoxy it. on the inside, and that usually protects the majority of oxidation for a very, very long time. But there's always a caveat and a catch. Epoxy doesn't do well with high heat. Valves do need to be powder coated. You do have to watch out for that. Okay. And um, that's about all you really need to worry about. Uh, you do kind of have to more worry about fuel management. So it's not just put more fuel in equal better. Higher oxygen under pressure with fuel means lower knock. So higher octane doesn't mean what it used to mean because there's more oxygen readily available to produce knock at a lower value of heat. So you can get yourself in trouble pretty quickly if you don't know what you're doing. That and natural aspiration, while is great, you are cutting 70% of your pressure. I know this seems weird, but nitrogen is a dense gas in the sense that it also is present while it sucks some of your heat energy. It's also extra gas that absorbs that heat and equals pressure. So when it isn't there, you need more now to equal the same equivalent volume of gas inside of your cylinder, which means you need the high flow nitrogen filter, and you will most likely need a couple to be able to produce very, very high amounts of flow that will equal a regular natural aspiration. That and that pass through nitrogen to the exhaust allows for a reduction of pressure, meaning overhead work energy for you to suck gas through the filter, as it's a Bernoulli, I think that's Bernoulli effect, because it'll suck in air and then the exhaust then gets used to basically act like a turbo for your natural aspiration because you have a filter, okay? But it's separated, all right? Which is good, you're going to want that. That effectively means you don't have a turbo, but you kind of have a turbo-ish like thing, right? And then now you should have enough airflow through into your cylinders, but you do have to be very, very, very careful to make sure you add air in as a methane injector, because otherwise you might run into a detonation velocity of burn or knock before you would like to. Okay. Knock can technically be considered, if done in an insanely precise way, a good thing, but not compression ignition. It's a technicality pre-burn before top dead center. That means you can kind of get a little bit more performance out of your engine, but that's based upon the shape of the head and the piston head and how it purposely compresses around the ring and then sends a shock wave towards where the spark plug is and rotates a pressure wave back down as it goes from top dead center back in, and it produces a cleaner burn. I only know of like a couple of airplane engine types that do that. Um, but I'm gonna move on. Uh, you have to be really careful with oxygen. Okay. Um, it ozone is cool. I saw the donut video. But ozone it takes energy. A filter doesn't take energy. A filter is just a filter. you pre-filter so that way you don't have any dust or debris, and then you filter with a high flow nitrogen filter. You just need to make sure that the line can't be oxidized too quickly, which of course, is done, right? But now you also need to introduce a methane injector, which is just going to be oxygen injector. Now it's standard natural aspiration, but the reason why you need the methane is because that's a direct injector. Now, direct injector is a bit weird. Why would you do it? The standard reason is always the same. You're going to run lean intentionally so that way you can burn after top dead center, so that way you have a more likely chance of having not too much pressure and not too much fuel that is immediately burnt. And so when you run rich like that, that means you have less likelihood chance of detonation, and that heat can absorb into the fuel, vaporize it to a very high degree, and then you can inject oxygen after top dead center and maintain a higher pressure and burn that extra fuel, such that you basically get what is very similar to a very perfect or very close to perfect stoichiometric ratio. Now, that's good, but it's very high heat, okay? Which iron is the primary one that you're going to want to use this for engine block. Iron blocks don't soak heat very quickly, and they handle higher temperatures better on average. But if you have aluminum, which is what most people tend to have, then you have to powder coat it, and you have to line the inside of everything with ceramic to help make sure you're not going to damage that by overheating it too quickly. Now, most of the time, aluminum isn't going to do that because you have cooling, but if it sustains itself for a long enough period of time at a higher enough RPM, it will eventually start to get in to it and cause failure. Uh, but if you line it, you shouldn't have to worry about that. But that is expensive. Okay, so it's that like, oh, I'm gonna go put a whole bunch of effort, but it's like it's not that much. Yeah, but actually it's expensive. Uh-huh. So it's like get out that old iron, from back in the day with the 90s, 70s, and 80s for Honda Civics and Toyotas and more that had iron blocks instead of aluminum, and drill out the coolant lines a little bit more and effectively run a higher coolant pump, right? Higher pressure, higher flow coolant pump. And that also is going to need you to run oil squirters to the bottom of the piston skirts, and that should take care of everything. All right. Now, blow by is going to be okay just because it's mostly going to be fuel. So, fuel is fine. You don't usually, during intake, have to worry about blow by, right? Um, Gasket, you're going to want to use a multi-layer steel gasket with a high temperature silicone material to help when you torque it down, just because it will then seal as it expands and rusts a little bit. All right. Exhaust is standard exhaust, but it's going to be hotter. So you need the low pressure, I think it is, sodium valves on the exhaust side, or you need to cool them with oil, right? Or both would be preferable if you could do it. Um, the inside of the exhaust port needs to be aligned with something to help just a smidge. And, and I mean that, yeah, with the heat. So you either cool it right there, or you line it with like a ceramic um, cooling powder coat, right? Which it's not really cooling, but it's reflective. It's like a reflective paint, and it's insulative. So I think Dr. Ben Miles did this aluminum thing recently on his YouTube video, and like those are cool tiles. But my thought was like, yeah, but like, can I replicate that? I can probably replicate that. I can probably. I mean, I don't get that exact, but I can get pretty. I can't get that 90 something whatever it was, but if I can get 70 in that port, it'll make it survive. Okay, 70 is really all I kind of need because most of it's going to be IR reflective back in, and it's already a little bit insulative in its own right, which then just needs the exhaust tubes to be able to handle the heat. Those typically run you a lot because you need titanium, right? And it's like, yeah, I'm not getting titanium. You know me. Like I'm the cheap guy. So no, I'm not getting titanium. I'm getting out graphite, and I'm gonna line graphite in the tube, and I'm gonna cut slots in a standard like steel tube that allows for my graphite to be effectively kind of bolted sort of ish, but it's really just another tube around that I'm gonna bolt like a clamp, like a clamp tube onto like the inner tube, which has now a graphite bar, which it's like that's fine. Like it'll work. Like graphite might burn a little, but it's not enough that I would have to worry about it. And if you don't want to get around that with graphite, then it's like, okay, fine. Then I have to get out quartz glass. Quartz glass is like a really simple one, um, because they'll handle really high heats. Now, I read a wonderful video. Actually, he's done a couple of them. That there's the diamond one and then the purple gold one that he recently released that goes over his quartz glass tubes that handle incredibly high temperatures. And it's like, no, they don't. Then he's like jiggling around gold inside of something while he's pouring in argon. That's a liquid metal. And it's like, no, they handle high heats. You're going to be quiet about that. Which then turns it into like they're relatively cheap. Like quartz is relatively cheap when it's a bunch of tiny little crystals. Okay? Shockingly, that's fine when you have a bunch of holes in a steel tube that act like a high flow resonator. So long as you make sure that there's a specific amount of spacing between all of them, it still is an exhaust manifold. It just now soaks the heat and spreads it and dissipates it over a longer given area, which now means instead of in a concentrated area, it'll melt, it will survive its given heat load. Effectively, you just put a few tubes through your manifolds, and then you put another like manifold over that. and you allow for it to transfer heat over a given distance. It's a high flow resonator manifold, effectively. I know that sounds silly, but that is what it is. It goes from this, and then it spreads out, and then so like take any part of that exhaust manifold point, and then it will cone outwards, sort of like those glass fireplace, installations people used to have. That would be, you know, pushed through with propane and some oxygen, right? They would burn and then diffuse out, but like it all depends on like how many small, medium, and large rocks and glass that they had, and that's essentially what the same thing is. So it'd have to be fiberglass. I'm sorry, not fiberglass, quartz and tubes and crystal stuff that allow for you to evenly distribute it, and that basically saves that. But that's because it's like, well, this isn't a racing, right? And if you want it to be racing, like, then just get a freaking insulative, like, your tube. That'd be way easier. Like, I know that sounds silly, but it's like the fact of the matter is, if you're just pay for it, you know what I mean? Like, you can just pay for something. Like, there is a convenience factor point where it's like, yeah, how much do you want to spend? Like these high flow nitrogen filters aren't stupendously expensive, but they're also not super cheap, right? And so it's like, well, what's how much money were you wanting to spend? Because I can easily increase that heat load, okay, by getting out, what was it, boron nitrate or something. Anyways, it's what they put in ceramic, containers that they heat up with microwaves. I just saw a YouTube video about it, about the material. Anyways, point is, it was like, oh, that's a really good high heat capacity ceramic, and it's cheap. They were like, it's super cheap, and all you have to do is just like heat it up and press it onto something, and it just sticks there. And I'm like, well, that'd be perfect. I mean, it's going to be a little more expensive, but I mean, it's effectively a steel pipe and some of that, and it'll survive. And I can easily do that little aluminum trick with the same thing on the inside of the exhaust. So that way I don't have to worry about it melting. The valve has to be thicker. Okay, so this is the counterintuitive part. Even though they are a low pressure sodium and you can cool them, thermal mass distributes itself better. Like, the longer it has to try and, push through all that mass thermally, it then means it'll survive for a longer period of time before it fails. Uh, Now, it's not the structure itself, it's still only this material design strength, and there's only so much you can do. But because it has to soak a larger amount of mass, it has a lower failure rate at a higher degree of temperature for the RPM, meaning load, tensile strengths, G loads, right, that they're going to go through. So, uh, get those big old diesel valves that have the low pressure sodium or something in them, and you probably will have them survive just fine because they usually hit temperatures that will absolutely be just fine with those valves, right? That'd be very similar to the amount of heat that the exhaust is coming out from that engine. So it's like, yeah, no, you can do this, but if anybody wants to know how, It's not terribly difficult. You just gotta put a little bit of effort into what it is that you need to basically mitigate what's expected to be there. Like, just think about it a little bit. Like, okay, what's really there? Oxygen coming in that's more likely to oxidize things. Most of mine is a fiberglass or quartz or something for the intake line. But that's because I run a super turbo on like everything now. Just because it means I can push way different styles of combustion. Instead of needing a detonation, I do a deflagration like a burn rocket engine inside of the cylinder, which maintains a degree of higher acceleration over a given distance. But if you ever listen to me, it's like everything is getting coated on the inside of the cylinder and the top of the head. There's not a single thing that isn't touched and changed on that. Even my valves are cooled. Right, and it's like, "Screw poppet valves. No. Rotating valves are the things now. Screw those things. Those move up and down and might fail. This just rotates, and it's always getting cooled by fluid that's making sure it's lubricated too." I don't want that anywhere near, you know what I mean? Like, every time I'm doing it, it's like, just that's a failure point, yeet it out. I hate that failure point. Everything about that failure point bothers me. This is now not a failure point. Eh. Change that design, change that design. Also, it works now. Yeah. Like, simple stuff. Just because something isn't being done right now doesn't mean it never worked, and it doesn't mean that it won't work. It was already being done in the past. Sliding valves were a thing, but also rotating valves have been a thing before. But I was like, well, sliding valves and a rotating sliding valve makes total sense to me. And we already have two-stroke engines. Who says I can't just have it coming out of the side of the cylinder? Why do I have to have it come out of the side of the head? That makes no sense to me. That's just more air intake space. You know what I mean? So, I don't know. After a while, I just sort of looked at engines like they're being done this way because it's manufactured this way. It doesn't necessarily mean that they're actually made more efficient this way. They've got a lot of design and engineering keeping them there and efficient, but they're not actually better. Like rotating sliding valves would be the only thing you'd ever really want to use. You have a way easier time of being able to cool it, time it, derate it, and even change its outright nozzle size, which is kind of like a lift, because that's just gearing. I mean, it's a type of gearing, you know. We have CVTs, we have gearing, we know what we're doing with gearing. So screw this lobe thing. I don't need to do any of that. I can have perfect all RPM valving for a given operation, right? Now, gearing then has to get changed more and more the higher you go up, right? But in terms of RPM, but that's doable. It's just more weight and some more complexity. So yeah. Um, anyways, I just want to move off because it's like, well, a naturally aspirated nitrogen filtered engine is doable for fairly cheap if you know what you're doing. Like diesel valves have existed for a really long time. We know what we're doing for cooling exhaust, but it's like if you want to get around cheap, then it's like just get a thick boy steel kind of or iron exhaust manifold, and you can probably make that work. Like, sure, it might glow a little, but like it'll work. The problem I have is that the head will soak heat over to the intake. And so I want to remove and reduce that. That's why I wanted to treat the exhaust port, and I wanted to have it be flowing a lot faster. And so if I treat a tube with like it's effectively like a pretty cheap little ceramic. I forget, I have to look that up. I think it's boron nitride or something. Anyways, they it apparently turns into not an octa, it's a cube. You know, like more cubonal in its lattice structure when it's under pressure. But it's like you have to heat it up or whatever. And it's like, oh yeah, no, well that makes total sense because I can do that. I know that sounds weird, but it's like not really. Like you can like honestly, you can just take like a steel tube and you'll put like pretty close to it other steel tube, and then you're gonna heat up one of them. That'll expand it, and then it'll dump all of its heat into the boron nitride or whatever material it is, and then it deposits it as you shrink it, rapidly cool that steel tube, and then you probably gonna need to do some electrical like kajiggeries. I mean, run electrical current or something through it, so that way it comes off the inner steel tube that expanded and dumped its heat. As you cool it, then it quenches, but it also condenses, so it shrinks, and then it makes it such that you're able to have that adhere to the inner diameter of the bigger tube while also having it. I think it's the electricity or whatever it is, but the blacksmith, just FYI here, they were like, no, we don't even need electricity. We have this thing called this whiteout paper stuff. It's like a paint or whatever. And I was watching Alex Steele do that for Damascus, like canister stuff. And I'm like, oh yeah, I know. Well, I'm pretty sure that would probably work if I'm honest. You know what I mean? Like, just seal up one end, seal up the other, and then it's like kind of mandrel bend to a degree, and then fill it up, or like get sections of that and then weld in between, right? And that'll probably get it finished in terms of an exhaust manifold pretty easily because you just need to heat it up. You can put it in a vacuum chamber, or you can put it in like just a regular furnace or something if you've got that. And same thing kind of with the inner lining of the other head. Now it survives high heat, but it's not insulative. So it's like it's fine for an exhaust tube, but it's like I need it to be insulative, which to me means bigger cooling lines. And if I could, I'll maybe do like a vacuum insulation, but otherwise it's like, how much material can I remove from this exhaust manifold that allows me to put an insulative ceramic inlay? You know what I mean? Like it's an inlay, right? Like you carve out the metal and then you fit something in that, and then you're gonna like bolt or whatever it is for welding or riveting or something. That piece there, and then you get like the ceramic around that, and then now it's kind of like a full functioning piece, right? That keeps it insulative. I can still widen the cooling right there, and I still have a vacuum, little line there for vacuum insulation, and it should all survive. Now, there's a bunch of fabrication, except it's like a tile here, a tile there, a tile there, a tile here. It's some heating in this area and a little argon pressure. So it's like if you know how to seal the valve and you know how to seal the manifold or the port, then it's like put it under pressure, make it hot, and then that should allow for the ceramic to adhere to the surface. And that would be pretty cheap to do yourself. Then it's just epoxy for your intake stuff, except for your port. You're most likely going to need to powder coat that. Just because I don't know how much I can trust epoxy around heat and a lot of solventable gas and oxygen. It's fine in terms of like the runner, like a port like injection wouldn't probably have too much to worry about, but like the port itself on the head is something that you're gonna have to worry about. I suppose I can get away with like a little bit of maybe that quartz stuff or whatever, maybe a fiberglass kind of style, right? And that might work, but um yeah, no, I mean you do have to have the direct injector just because if you make sure to run rich, then you don't run detonation or compression issues. You just don't run into them. But that also means that you have something to also um, absorb a lot of that heat, but it doesn't burn. You know what I mean? Like completely. It's a lower pressure kind of thing, which can be good, but it can also be bad. So a good way to put it is like, oh, well, before I was getting like 1500 psi at top dead center, and I was expecting like more than that, right? And it's like, well, yeah, because you're running so rich that you actually don't have the ability to run at 1500. You're doing maybe 1000, maybe 1200, right? And if you inject after, as long as the nozzle, okay, so the pressure inside of the injector, it just needs to be the right amount. And then after that, the nozzle tip and the size is what's actually seen as this PSI. Okay. So if it's at this, let's say it was um, regular atmosphere, so like a standard 14.8 or 14.7 or whatever it is, that's one atmosphere, right? Because you're still on Earth, all right. But that only means you get like uh, the right nozzle size, maybe 1500 psi, right? Well, because of the timing of that injector is going to be delayed. Top dead center is really far up, but because it immediately rockets downward because of a angle of the connecting rod, that means it suddenly drops down to around 800 or even 500. Now it depends though heavily, truthfully, on the amount of gas that you have and how compressed your engine really is. So if you have a higher compression kind of style, of course you maintain a higher PSI for longer. But um, anyways, moving on. Uh, that means you can fire that injector for that air, but a little bit of help, and I mean a small scotch, like literally the compressor that your AC runs would help tremendously for those I mean a serpentine belt, little tiny, like a horsepower, maybe three, you know what I mean, at most, of a compressor that takes that oxygen, puts it into a bottle for those injectors, then ramps it up. Because if you know about refrigerant, that's like 100 and something psi or whatever, right? But it's like we're not gonna go to that high. We don't need to. Like 50 to 60 at most is what I always seem to use, and it's because I can easily maintain 2000 to 2500 psi out of most methane nozzle size. Uh, uh, for the injectors. All right. So the injector will pulse at the nozzle as a 2000 to 2500 psi in injection. Okay. Now, methane or propane are usually like the big boys, but um, what I found is any of them that are rated for gas will do oxygen. It just depends on how long you've got for them. So if you're willing to like change out that like nozzle area by drilling it out and then placing in a quartz tube, like a little tiny quartz tube, like a little bit of modification. So it's like a little bit of that quartz in there and a little bit of like epoxy or whatever towards to where that injector is means that the line doesn't degrade over time. When you inject it in, it then is able to pulse many times instead of just once, and then it sprays like a nitrogen oxide, like a NOS injector. You can get actually multiple pulses for longer durations, and that can help you equal a better stoichiometric mix, which is good. Of course, you are increasing heat while doing that, but of course, the piston is going uh, to bottom dead center, so the chamber is now expanding, and that means you actually conserve that as increased torque because you increased acceleration. Now, unlike what I'm doing, you don't have to worry about middle dead center slowdown because I'm basically deflagrating 1500 psi and then I'm maintaining a 1500 psi as a volume is expanding, which means I'm actually accelerating my piston a lot more than a standard engine would. Engines decrease in pressure over time. Okay, I'm maintaining pressure, which means I'm accelerating incredibly fast. Now, if you want to do the opposite of this, then, uh, great, you can go back to normal, regular combustion. But a little bit of injection of air, oxygen, after helps out a lot. And that just means you get an increase of pressure that's maintainable, but you don't have to worry about the middle dead center problem, and you can go to bottom dead center and still keep trying to burn. Uh, but what I'll tell you is it has to slow down. Okay, so the piston has to slow down at bottom dead center. Like it can't, it has to slow down. Okay, so the middle dead center is still a thing, but it effectively slows down less. So it'll speed up and then it'll speed up a little bit more, but it's going to start slowing down anyways. And so it's just going to slow down a little less. And uh, you can still burn a little bit after middle dead center, but you're not going to get a lot of extra power out of that. Like all you have is that stroke length for that to that middle dead center. That's really where the majority of your power comes from. But you can kind of get a little bit after that, but that's only because you're not at limits of the piston speeds that you can maintain. Okay, which is good, but be careful. Uh, it's always heat for most people. For me, it's not about heat. It's a increase of pressure near where the head gasket is and the head is. Because as it expands away, mixtures of gas and fuel are still there, and you're introducing it, and it'll burn where the nozzle is and where the head is, and then that pressure wave has to travel, and that heat has to go somewhere. So a lot of it gets soaked there, and then it travels down. And so you have to pulse it rapidly. I usually do many, 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 many small pulses instead of big, big, long pulses because that means it'll pulse, it'll move down, and if I wait and pulse, it'll move down. I wait and pulse, move down, instead of big whoosh. It's a big overpressure moment and a lot of heat, and the heat gets soaked where the gaskets are and the head is. But if I pulse it, then it has a chance to move down and the rest of the heat to go into the rest of the chamber. Okay, which is more survivable to the head gasket and head and the cylinder than if I were to try and burn it the entire time. Okay. Uh, then it's just about cooling valves, making sure your valves survive. Valves have to survive a lot of heat usually and pressure, but usually not quite as hot as this and usually not quite as oxygen rich on the intake side for what it's worth. Like that intake is going to be experiencing a very high heat load and it has to keep that heat under check where it's at the bottom. So most of the designs I usually went with is the ceramic coating on the head and the valves, purely to make sure I didn't have to deal with that having an issue instead of like trying to survive. It's all insulative. Like everything you'll hear about me say is it's insulate, 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 just never ending about just make it not absorb heat, just stop absorbing. Because I kept having after a point, whereas in the 20K range, right? So like 18 to 21K, so 18K to 21K, I would sustain a consistent enough heat load that I couldn't transfer it fast enough that I eventually started getting knocked. And so, because I'm that guy that's like, I just love high RPM. Like high RPM is my jam. Okay. And then I was like, well, why don't they have longer stroke length high RPM engines? And then I figured out a way around that with materials and shape and geometric designs and installation ceramics and hard ceramics to reduce frictions and then burn. So like burning from a initial burn, combustion, and then burning after to continue making sure it could actually get some degree of torque. But of course, that means I had to turn into, oh yes, no, I need a crankshaft variable valve duration, which means the crankshaft will slow down and has to dump because it's on a gear into a flywheel that spins it faster. And so, like, because there's a mass there that resists that, it then can't do it. And so it hangs for a little bit. And then it was like, well, if I have that on this type of gearing, that means harmonic balances for piston acceleration can be mitigated a little, not much, but a little, right? And then that's when it turned into the world's best, in quotation marks, anti-gyroscopic inline four. That's when it turned into that because it was like a bunch of those gear things and pivotings and all this other stuff. But if you don't have any of that, it's effectively just a gear that's attached to the flywheel that's made very specifically to help match the either flat or crossplane type of crank you have to help reduce those harmonic imbalances and standard primary, so secondary primary imbalances. But it's really just because I needed to get more air and I hated lobes. So shockingly, most people don't know about this, but the outside of a circle spins faster than the center. And so when it rotates, it actually starts spinning faster and faster, right? And it's like, oh shit. Why can't I just slow this down when I want to? Why don't I have a CVT attached to this? I can put a freaking gear to here and it's a ball and a ring, right? And I looked at Robert Murray Smith, who talks about a ball and ring CVT gear, and it's like, that is literally perfect. I don't even need to worry. It is RPM matched perfectly for my duration. I just need to worry about lift. And then I came up with a whole bunch of other different ones over time. But that's literally what that was. I was just like, well, why don't they just do that? And it turns into, I have to make a ring and I have to make a ball. And I'm like, yeah, manufacturers, you make bearings all the time. You make ring. What? What did I just hear you say? Where are you going? Huh? Huh? Oh, you can't make this. You do this every day. Where are you going? Where are you going? Anyways, point is, moving on. It was just like really simple after a point like that, but then it was like, oh yeah, no, cone gears can still work because those are pretty easy, for CVT. They just happen to have a frictional component that's usually not something people want, right? And then I was like, well, then I'll just turn my intake into a supercharger that's actually my valving. If I rotate it, then it opens because I already know about rotating valves anyways. So it's like, you know what I mean? It's like, well, then that'll just, like beeswax cylinders and whatnot, push on something. But it's like, yeah, but that's just a hydraulic fluid, right? And I already have to have a hydraulic fluid there, and I already have to pump it, and then I already have that for valves. And so now it's a supercharger that's cooled and it does my valving for my intake and exhaust, which is in one of my videos that I added somebody just because it was like, well, then why don't you just do that? I don't need a if it's parasitic loss anyways. It's literally going to be parasitic loss anyways. It's a camshaft. It is a big, heavy moving object, and I have to bolt it to my crankshaft and everything. Supercharger that has bumps on it, like, the rotating, props on engine airplanes, right, to stop bullets from shooting their props to death, for gunfighting, dogfighting, right? And it's like, oh yeah, like beeswax cylinder is usually what most people tend to remember, or those little like ding dong ding ding ones, right? Right. So it's just like, oh yeah, no, that's literally exactly how you can run your valves. You just need to make sure they're positioned the right way. And it's like, behold, the manifold of the intake variety. That is my camshaft that also allows me with a few solenoids effectively to change my outright duration by just simply extending a plate that it like a bucket, right? So that way it would durate it for longer. Because that would be way easier, and then I can get it closer, which means I get more lift, right? And then it's Ducati time, folks. It's like open and then close. Screw your darn springs. Where are these coming from? No springs here. You're closing because I said to close. Programming language stuff now. Instead of, I expect you to do this properly. No, I executed this command that says you're doing this exactly like this. That is literally what I did it as. I'm not even kidding. I was like, you're closing now. Just be closed. Uh, Same thing for my exhaust, for what it was worth. But it was like, there's got to be a way to do the CVT in there. And it's like, well, no, I have to have bearings in there. So I might as well have the bumps and then like a ball, right? So it's like, that means I can change its gearing ratio for the outer, kind of thing to the inner, which means I have a CVT to the supercharger, which means change it at this given RPM consistently through the gearing ratio. So it'll be at a higher, so it'll spin faster at a lower RPM, and then it'll go to a lower RPM at a faster RPM for the engine, respectively, right? And then it's like, now I also have valves, right, that can change based upon that as well, that change my duration, lift, and timing, right? But that's placement in the solenoid on the bumps, so a little earlier, and then a little closer for more lift, and then a little bit more elongated for restoration. But that also means because I have a better gearing ratio, I might have higher physics loss at idle, but at top end, I actually lose a lot of that parasitic loss because I'm maintaining my pressure coming in more evenly. So it's a more flat, curve, right? And boost was suddenly there, right? But it's like that's not something I like often with turbos, just FYI, I'm not a big fan. And then superchargers had this issue for me of I have this one static fixed gearing ratios. It's just a fixed gearing. This is it. That's all I get. Yeah, but at top end, I don't want that. Like, I literally don't want that PSI. Like, I can't handle it, which means I have a limited top end RPM if I have a supercharger. So 5, 6,000 instead of like maybe I want to go to 12. What if I wanted that? And it's like, well, shut up. No. The answer is basically you can't, right? And of course, me being me turns into, yeah, I don't like that. You can't tell me what to do. No, I'm gonna do what I want, which is literally what that is. Because I'm that guy. I'm like, no, I can put a CVT on this. No one says I can't do this. No one says they have a super turbo that disengages the compressor. They have a big long axle connected to these turbos in the rear here on this V6. Okay? That is like a firewall. It's way colder. Okay? That's really cool. I'm just saying there's nothing that says I can't do this. They can disengage the supercharger for the turbo to take. You know what? Screw this. I can do this. And so I was like, well, I looked at scooters, and scooters are CVTs, right? But they're like Venerator, and little, and then bigger, and then the belts, and they wear out, and a whole bunch of. I don't like it. And I was like, Robert Ray Smith has a lot of cool things there for the ring and the cones, right? But it's like, I need a clutch to get you. Man, I mean, I want it to be electronic at this like RPM, you know what I mean? Or do I? Do I? Like, right? Like, do I? I can still have that there as my main, but it's like, I still have the ability to use a clutch. Nothing says I can't use a clutch. I can use a clutch. And so for a long period of time, I was using a Venerator from off of a scooter in my designs as like a basic cheap. But it was like, they have a lot of these CVTs for pretty cheap, man. These are pretty easy to find. Like, honestly, just do that. Just be quiet. You know what I mean? I know what you can do that. And then it was like, oh yeah, now it's a way better gearing ratio. I have a supercharger that is also my. Is it well? Okay, a good way to put it is as like, what kind of what? What's a soup? Okay, what? Right? And it's like, okay, so a rotating mass doesn't automatically mean you get compression, but a statically fixed mass, okay, but then you have a rotating mass on the inside. All right. As you intake, it then goes from a central point to a more small area point, which now has compressed it. But this is the big key difference here. If that rotating mass on the inside is hollow during the moment of opening of an intake, it then rushes the entire cylinder of pressure towards that. As that happens, when that closes, it rebounds out. And if I do that such with the inside hollow mass, which means it weighs less, of course, and you don't want that. It also means that there's a way to make a bearing and an axle and a whole bunch of structures to cool it on the inside. It opens that to like a two-stroke engine that has the rebound pressure go inside the hollow point to the next opening cylinder, meaning the next valve opening. And so it'll take that rebound pressure and then the intake pressure that's coming in and shove it all towards that. Now, central to an out is the equivalent of turbines, right? But turbines aren't super great. Just FYI, they're really actually not that great. They're stupidly not efficient. I don't like them. But that was to imagine essentially the start of it. So it's like it's gonna go from the center out, right? That's a smooth transition. But we're trying to actually wrap it towards the rear, which is why the stators are there and the bumps that help, right? That rotates it from the outer tube, which has the stators, which then is going to take it from a certain size to a smaller size, wrap it towards the not actual inner hollow. So that's like 3 tubes here is what we're talking about, which is, yeah, kind of like a Jules Thompson, but it's not quite a Jules Thompson. Anyways, it goes in, it has a parabolic spike. Shockingly, a parabolic spike is great because that means you can have an axle right there in the center, nice and balanced and aligned. Yeah. Anyways, it goes in and it comes over, and then that's now its pressure vessel, right? So the reason why I personally like it is because it has a huge plenum volume, right? It's basically just a smooth surface as a pressure vessel that will just dump into anything, right? Right. I have to have people imagine the fact that there's like, how do you do a two-stroke? What is this? Like, honestly, okay, how does that work? Right? And it's like, all right, so the axle that goes through is to spin the wider tube, but that wider tube is, while smooth, not exactly as smooth as you think. Okay, it's not because it has like the holes in it, but because it's going to line up with holes that are on the hollow side. So they're there and it's around that, and so then it will line up and then flow through, right? That's fine, but I don't want those holes to be what you might expect. I want them to curve in and actually help at that moment to scoop in that pressure area wave to help combine that into the next uh, intake stroke, right? Now, that one turned into basically just it's a real tapered to the initial intake, and then it's a scoop that is actually kind of around that area. So it'll try and grab it as it's rotating, and then it'll go through, and then the inside is effectively a screw like a rifling, right? But then that actually helps as it turns to because it's not technically rifling and it's not technically screw. Anyways, point is it's like the stators thing, but that means it grabs the air and it sends it to the next intake. Now, for a V8, it means I need a octahedral, so or octal helical stator setup, which i- is exactly what you think it sounds like. It's a helical, meaning screw, but there's 8 of them that are specifically made to constantly rotate multiple double forward and backward moments, and that's passive programming. effectively. There's no changing it. It is static. That's all you're getting. There's a hub, but that also means it'll open up and then it'll move on and it'll open up and it'll move on, open up, move on, and all that. Uh, it's a bit rough, but it works. Uh, but it was like, well, I'm gonna need this big parasitic mass, right? But it's like, right. Well, luckily now it's essentially the same weight as 4 camshafts, and the result of belts, the gears, and a whole bunch of other stuff that you have to have there, right? Like it's actually a lot there. I effectively made it like a flat V8 because I barely need any real valve covers. I was able to angle those valves pretty substantially for that, which is great. Like honestly, that it means I have a diagonal vertical, so it's like it's off, and it's off to the side, but then it's a angled valve. So like the angled valve is like a duck foot or whatever, but then it's like vertical and then off to the side, right? And it's angled inward towards where the V is, and that all helps with flow. So come in, and it'll try and vortex to skip down. Now, that's the progression of these poppet valve things that I started doing until I eventually went, yeet, fuck this. This is stupid after a while. I'm just gonna make a fucking rotating sliding valve. This is the stupid. I'm over this. I am so over it. Like, you have no idea. Uh, I don't want to do it anymore. And, it'll balance it now with the rotating valves, and I just need a ball and like a cone there, and now I have 2 plates that'll rotate, and then like that'll be like slight timing and then slight amount of nozzle if they're together, or like full open, or uh, it'll slow down because it'll like open up a little bit, like kind of like a clutch, right? So it'll move off of it, and then it'll suddenly be like, oh, I'm gonna be right here for a little bit longer, and then I'm gonna go away. That kind of thing. Anyways, you might not be able to do all that, but like I just hated camshafts after a while. I was I was just so angry with camshafts. I just couldn't handle it after a while. I kept looking at him like, this is a parasitic loss, and it's rotating too fast. No matter what I'm doing, I wanted to literally throw, like, I wanted to beat the engine. Every time I looked at it, I was just like, just you get a hammer and just hit this fucker. 'Cause it doesn't work well. It doesn't do timing well. It doesn't do anything really that well. It does it well enough for about 100 years ago. But we know about gearing now. Like, we know all of the, like, we know about this way better. Like, we don't need to do this. I can make a hydraulic fluid line. I can do a hydraulic ram. Like, I can do a Ducati push, but it weighs less now. It push and pull, right? But it's like a hydraulic ram. So it's like you push it in and you pull it back. That's all you're doing, right? And I don't need anything to rotate. You know what I mean? Like, unless and it's what am I just get too fucking, what is this? You know what I mean? I don't get it anymore. I'll just make a rotating sliding thing, and I can stick it and then clamp it, and then that's like a bolt, like kinda, thing, bolt it there, but it's like you need a spark plug there anyways, so right? And now that's a bearing, double rotating, that's the gear, all that, and it was just, like, super simple and quick to do. Uh, but then no direct injection, which is why I ended up turning into, I now have a rocket injector, screw intake. I'm making this she'll just dump fuel in, and then I'll put a little bit of air, and then really extra lean mix, after a little spark gap there at the nozzle, and then I am cooling it with my fuel like they do with the rockets, and I'm done. I don't care anymore. Like, super simple, easy to understand kinda stuff for me, and I thought, like, everybody else kinda understood it until, like, well, why the hell aren't they doing this? And it's like, well, this is a rotating part here. They can't, well, I mean, you have rotating parts, you have a camshaft. You know what, man? I'm just saying that this injector can rotate and then it has a rotating part. And that's effectively a pump and a compressor. That's all they need, man. I have a mechanical pump and injector from a regular natural aspiration. That gives me all I need for my injector. I don't really need more, you know what I mean? Like, it was like, they have one-stroke injector and technology. I tweeted about this a long time ago, and I'm like, "For aviation or something, and they're developing." You should have had this ages ago. You know how rockets work. What are you doing? It's just pumping in air and fuel. That's all you what is this? Anyways, that was the progression, especially when it was like, well, nitrogen filters exist. Veritasium did a video for nitrogen cold brew to filter out nitrogen from the air, and then they chilled it off using acoustic resonant, like, chiller or, cooler or whatever, and I was like, "I can use that. I can fucking use that. There's nothing saying I can't use this. I can easily get that oxygen. There's nothing I can do this." 'Cause it filters out the nitrogen from air and it leaves whatever's left. Now there's still argon, there's still some nitrogen, but mostly it's oxygen, right? And then I get the best of both worlds kinda thing, where it's like I get a really, really high heat, but of course I need to make sure to inject air after top dead center. Okay, like you have to have a leaner mix in no way. Like you literally can never do a lean mix. Like, the answer is no lean mix, you cannot inject fuel after it explodes. It is the very opposite of a compression ignition engine, for diesel that injects fuel. It's a compression ignition engine that already has a burn going on that has to inject air as your fuel. Yeah, like, fuel is what they always use, but it's like, yeah, you can't use fuel. It doesn't burn well, like, it doesn't do anything very well. And so if you directly inject oxygen, it burns more consistently as it travels in the chamber. And fuel is already going to be vaporized, which means it'll deflagellate, combust much slower, versus if I were to try and dump fuel in a very high heat, oxygen rich environment that's under pressure, which will rapidly decompose and detonate. So you can't do fuel. You have to do oxygen as the injection. People don't often understand that. I'll do fuel injection. No, you'll do detonation to your engine and break it. That's what I heard you say. You will burn the oxygen. Just burn just why don't they ever understand that though after a while? But it's actually like, oh yeah, no, that's understandable because shockingly, most people aren't given that kind of education, and I wasn't, and I had to learn off of a bunch of YouTube and checking, is this possible? Other people tried this, and then there's articles, and then there's science, and then it's like, what's the physics and this and that? Da, 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 da. And so then it turns into, oh yeah, no. Fuel rapidly decomposes and burns inward from the oxygen. When it does this, it creates a massive electrical current that arcs out and in. As it does that, it then vaporizes under immense amounts of compression while it's still cold, technicality wise, if it's thick enough in terms of vapor. But then it burns outwards, then compression ignites and then detonates. So it's like a lot of these electrons are there, and as it does this, it rapidly Z pinch currents everything outwards. It then rapidly yanks a lot of hydrocarbons apart and then tries to mix everything extraordinarily quick and then pulls oxygen in because it needs an electron now. Then it does so exothermically very quickly. It has a high kinetic potential. Then it detonates really fast. So it spreads out the fuel and then it really quickly burns. That's effectively what the physics are. I'm not even kidding. Like if you just shove in oxygen, it's like, oh yeah, no. Oh, do you need me? Oh, hey, I'm over here, hydrocarbon, just hanging out. Oh, hey, what's up? Oh, hi, hi. You know what I mean? And it's like it slowly mixes and it does its thing, right? It still burns really fast, but it's deflagration. It's a combustion versus an explosion. Oxygen is more reactive when it's hot. Okay? Effectively, there is no oxygen left. That's what a rich mixture is. Because it's very hot, though, it's very close to decomposing as fuel, which means as you pulse in oxygen, you control the burn and the rate at which it will burn, and for how long and how hot and more. When you shove in fuel as a hydrocarbon, it will rapidly soak up a lot of very energetic, highly reactive oxygen that wants to make it burn as quickly as possible. I'm being very, very loud and aggressive because somebody just doesn't. I can tell right now. I can tell, like, no, it's a detonation. You get a detonation. You don't want detonation. You do not stop that. Stop that. Stop that. Stop. Like, no, I get a nice, like a, rocket burn or whatever, right? There's no detonate, right? Or like a jet engine, okay? And then this guy's like explosive. I want C4 happen. No, you don't. No, you don't. No. To put it in perspective, it seems like that might be a good thing because it's a really good efficient burn or something, right? The problem is that it's a very fast shock wave that is very much like I have an impact wrench that I then decided to hit with a sledgehammer. It's like ding 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 dunk. Ugh, it broke it. Oh, I wonder why. I wonder why it would break. It rapidly moved the surface level, which is by the way much hotter now, of the material much faster under a much higher G load than it can sustain material strength wise. It then proceeded to have that shock wave go supersonic through its material and then broke it into a bunch of cracks and pieces. It'll find anything it can do because this thing compressed like I hit it with a sledgehammer and you see a big dent, right? And then it's like this other stuff then wanted to get the hell out of the way. Well, I can't because there's a cylinder wall there, which now then suddenly means crackety, crack, crack, splintery, piecey pieces all over. And where did my rod go? It's in the concrete underneath your freaking engine. How did you not see that? How did you not see that? Like, honestly, also, where's your head gasket? Did you notice your head gasket's gone? Did you notice your head's basically bent as fuck? Do you notice this? I noticed this. I noticed all of that. How did you not? I don't know. Are you drunk? Literally, wow. You know what I mean? But that's the thing. People have done it specifically with multiple injection diesel compression ignition setups. So they'll burn an initial diesel, but it'll be a very high amount of extra oxygen because they'll usually just buy a bottle of oxygen and then they'll pump it in. Not exactly smart, but still. Anyways, uh, I always get I always seem to have an issue with this one because it's like I've seen these and they're really cool technology for what it's worth because what it means is if you pump diesel in, inject it multiple times, you get a better air fuel ratio burn, but it's really just for given types of torque. So it's like as it accelerates away, it maintains a higher degree of pressure as it gets to metal dead center, and you get a bigger torque. But it also burns a lot of the particulates that it normally wouldn't, which is nice. However, it's just because of incredibly high amounts of heat that then soak in and then shockingly burn that. Hmm. But it's like, where did the extra oxygen come from? From an oxygen tank. I just said that, but okay. Whatever. Anyways, that was what they were doing back when they had a super or turbocharger setup, right? And these are usually really high performance, big boy behemoth engines. So, like, we're talking, they're almost not used in regular on the road. They're like Caterpillar trucks or stuff like that. And they'll inject multiple times, right? And they get really good performance numbers and they can handle it because there's a big amount of mass and all that going on, right? Anyways, shockingly, somebody knew about it and was like, "Oh, I'm gonna pump in oxygen because I need it to get really hot." That's what they're saying that's really good. We should do. And then they're like, "Man, I'm gonna get these solenoid injectors instead of mechanical pumps that then will pump multiple. I'll just ECU tune it to pump multiple times at top dead center and a little bit after." And while it worked ish, there's a very specific tuning profile you have to do for that to be something that doesn't just make you roll a bunch of coal. And there's very specific timing intervals for RPMs. So there's pressure and timing at different RPMs that have to be maintained because there's a pressure wave rebound off the piston head and a resonance frequency that increases heat and pressure where the injection happens and helps with the burn, right? Even though it's quite hot and it now has more than enough pressure, it helps mix the particulates and burn it better, right? That is not what they did. They added more oxygen from a bottle and then injected as many times I guess they thought they could. And as the story goes, there isn't an engine that exists anymore. And shockingly, they told everybody it was because of something else. not the oxygen bottle they bought and they said they were gonna do all these cool things with it. No, it was something else and bad engine design and so on. Crazy, right? Could never have anyways, I'm gonna move on. Uh, but they were able to get something out of that, mostly as a if I burn a, uh what was it that they did? It was a different fuel, like a water meth, but it wasn't like water or methanol or any of that. But what it meant was is it would, absorb the particulates, right? And then it would burn them, but it had to run extra lean to do it. And I forgot what the hell the fuel was. It was like some, real solventy, like almost turpentine kinda thing, uh, basically. So but it worked. Worked really dang well, actually, yeah. Uh, so there's that, like, if you wanna clean your diesel, I suppose you could do that, and you do get more torque, but you are gonna use a lot more fuel. So, potato, potato on that one. Anyways, that's the long and the short of a natural aspirated nitrogen filter engine technology that you will have to effectively adapt. Like, it's all well and good to have a nitrogen filter, which, by the way, if you didn't know, amazing, right? Like, oh my gosh, cool, fucking amazing. And they're cheap enough that they really genuinely should be looked at. Um, Seriously, it's just a little bit of upgrading to the intake, either a silicone or an epoxy or something like that that is less oxidatively um possible. Like it's less likely to oxidate, right? And oxidize and all that. But anyways, point is a bunch of words that mean reactive to me. That's what they mean. Like they're less reactive. Like oxidate, oxidize, oxidate, it's reactive, right? But then it's like the only real issue, because the vast majority of engines do handle high heats and high pressures, is you're really making sure you just don't overdo it. If you make sure to run rich, you're always going to be able to add more oxygen in easily. And you only need a little bit of a compressor if you wanted to. You don't even need them. And I mean that actually, but a little goes a long way. And an AC compressor is usually like 10 horsepower or something. But it's like, yeah, but I don't really need that. And that's a gearing. I can make that a smaller pulley. And yeah, okay. So I got it from a junkyard and it's not gonna last that long, but I don't need it to, right? Like I can get another one of the like I just need proof of concept or like just a thing I'm using now, right? Until I get like the powder coated whatever that will last that long, right? So I do that, burn it after top dead center because that's usually the really fast movement of the piston, and that's kind of what my new top dead center is. So like you usually burn before top and then it fully combusts, but this you don't really need to do that as much because it burns so much faster. So it's kind of like a higher hydrogen. Like hydrogen burns really exceedingly fast. Fuel will burn exceedingly fast now. But that's why you dump rich in and then you burn after because extra fuel slows reaction, right? And afterwards, when you burn after that, that's like your new top dead center that is much easier to keep and maintain a given type of torque profile to middle dead center. And then it's really just about making sure you cool it a little bit more. And that's kind of where you can kind of end it because Most people usually don't wanna powder coat the top of their piston heads, but if you're gonna do it, like, it's not that hard, or, like, a lot of those little upgrades are really doable in a garage or something if you're able to get a space to do it, and, or just pay for a convenience fee. Like, I'm not even trying to be a mean person about it, but it's like, if you're willing to, you know, I mean, it's what is that, like 3 weeks? You know what I mean? Like, you know? I don't it's a lot easier for a lot of people, but of course, it's much more expensive now. Like, the convenience fee is almost always 3 to 10 times more than what it would cost if you wanted to do it yourself, especially when you have to insulate something because it's now high performance and high all the things, and, I don't know. But as a proof of concept, if you want to try it, intake is your best bet to make sure to maintain, and making sure you have a direct injector head that you just modify the port injection by effectively drilling and tapping and then welding or JB welding or whatever it is you're going to do for your port injection, right? And then it's methane injection all the way, or propane injector, whatever it is, and a little bit of compressor, and probably want to stick to those thicker manifolds. Um, since you're probably not going to be racing on it, you are unlikely to have that heat soak come in. You know, like that's for like you're sustaining higher RPM, and you kind of need to. But for a regular everyday, it actually improves your fuel economy a little because you can get away with a lot less fuel because you can make more performance out of that given oxygen, right? Which a way to put that is I can run leaner, but I'm actually not running leaner, right? Like I can now use less fuel because I have more oxygen and I don't need as much air put into the cylinder to do it, right? Because I don't have nitrogen. So that means I can run a higher nitrogen, I mean, higher oxygen, but like I can run a lower oxygen amount by having timing be a little bit different on that. And that allows me to get kind of away with a lot of fuel changes effectively. Like I get away with a lower fuel use. Normally they have to lean it out though, you know what I mean, which runs it hotter, but you can't really do that. So this one would turn into, well, it's a very short, like a real like a little bit of that goes a long way, but like you have to run rich, which really means it's like, and yet I'm not gonna have that valve open. You like practically for almost any time if I can do it. If I can figure out a way to like just stick something like a throttle body there, just no, no, just go away. Like, what? Just go away. Get out of here. No air. I don't want no air. Anyways, um, doable by the way. We were talking about individual throttle bodies. Uh, they almost never do them because it's like, yeah, but I did this for performance, and well, yes, no, I absolutely love fuel economy. I'm gonna get vroom vroom going, and I'm gonna see realistically because if I get an entire cylinder that let's say it was 1 liter total, but before it was like 70% nitrogen. Now it's 100 or well 98, 99% oxygen. That's a lot more fuel I can use. That's a lot more fuel, right? But of course I can't really use the same technique, which means it's like that's actually a lot more fuel than you thought. It was actually not that much fuel. Um, you needed more. I see what you're saying, right? You know what I mean? Like, I need more fuel. That's what it is. I need to inject after. That's what that's gonna be. That's a separate injector. That's gonna be like a separate injector pulse, and then that's like delayed or whatever it is, right? Yeah. Mm. And that's all it's gonna be. And usually that tends to mean a torque value that's pretty high. To put it in perspective, like a naturally aspirated wouldn't ever be able to achieve a torque value like that without forced induction. So it's stupid to say this because it really depends. Okay, it really heavily depends on what your altitude is, the number of nitrogen filters, the speed that you're going at too. All play a heavy role in it. But uh you typically can go, let's say it was 150 horsepower, right? You are more than doubling that if you do that. 70% nitrogen is great, but when you remove it, it then means you have effectively that almost that 70% back, except you even have more fuel because you're going to inject more oxygen after, which also continues its acceleration after top dead center. And so you will get 100% and a little bit more. Typically around that 120 is about the top. So you should prepare for that. 150, double 300, and then you add the 20% of 150, which is usually what that tends to be. And we're not talking like sea level, we're talking like 5,000 feet up, which is however many meters or something. But it's like, let's see, 150 times point 0.2, because even I have to do that. So 330 horses, which is not bad for some filters and injector, right? And like you got to do a little bit, but it's like that's a serious upgrade. That would be comparable to like $5,000 of a forced induction intercooler and all the rest of it, right? But okay, so nitrogen filters are plastic, so they weigh less. A compressor that's a AC compressor weighs much less than a turbo or supercharger. And then the exhaust that goes, the intake for the nitrogen that goes off into the exhaust helps cool it down anyways, just FYI, right? But also draws more in. Now, we're not talking a whole lot, but like it is a decent amount. Um, but that's less weight than an intercooler is, along with all the very rigid, stiff metal piping you're going to need for it. Uh, from what I understand, the nitrogen goes one direction, and then oxygen is what you get from around either the outside or something. The way it looks is it looks like nitrogen. is like passed through on the bottom, and then the outside is like the oxygen or something. I forget what it is, but that's effectively what it's doing, right? And anyways, just wanted to quickly interject that because it's like it does seem kind of difficult to understand, right? Yeah, and it's like, eh. But it's effectively you'll be able to know which point it that way, that's the oxygen, and then that's the nitrogen, right? Like, like, they'll probably give you a diagram or whatever, but because it doesn't just store the oxygen and everything inside of it, and then you have to eat it out, right? Like, it's gotta go somewhere, so, that's kinda what that is. Anyways, um, moving on, uh, that's effectively around because you can use around, you know, uh, it's probably amount of the nitrogen filter and some tubing and so on. So like it's basically the same as that, but with a lot less weight. Uh, You just, but I mean, that's a high tech versus low tech. You know what I mean? Like, or versus low for donut on that one, because I would absolutely I would do that on the low car so fast. I'm getting a nitrogen filter. I'm doing that. I'm doing, you know what I mean? So fast, and oh, you're getting your turbo. That's really cool. Brrr. I'm gonna pull more oxygen into my engine with my exhaust. I'm gonna do that. And I'm gonna be cool guy over here. This guy. Just letting people know. Uh, it's just most of my designs are all super turbos for a reason. Because it's like, yeah, no, that's great for like maybe 10K, maybe 12K. Uh, But you need more air. You need to suck in way more air. You need to do a lot more work if you want to get up to those higher RPMs. And a super turbo is always welcome. So, anyways, I just wanted to do it naturally aspirated because like a lot of people might not be willing to do that and all the plumbing work and all the line work and all the way and they're like it's so much more weight and I'm like yeah I mean yeah I mean if you're gonna do a super is it you know I guess, yeah. I mean, yeah, no, okay, like, yeah, okay, I'll give you that. Yeah, yeah. No, I have to give you that. Except, but also, wait, what about the fact that I don't need nearly as large of a turbo and I don't need nearly as much of cooling? I don't need nearly as much of, in terms of that, right? That I would need for a much larger system because all of a sudden I have a nitrogen filter. And that weighs a hell of a lot less than all of the rest of the components. So it's like if I was like, I'm gonna do a super turbo anyways, I'm gonna save myself like just bonkers amounts of weight. So oh right, and then I wanted it anyways because it was like, well, all my turbos are usually bigger turbos. They're not like the smaller ones. And that helps with efficiency, but it's more weight. But what I do for that efficiency is it's not just to help the supercharger, it goes into my crank all the time. Like I always dump it into my crank so it goes into my transmission. And that improves my from exhaust to actual real world torque and horsepower performance. Instead of needing an MGUK, which Formula One does really well, and on all that, I just have a really hard time uh, doing that. In my mind, I'm like, well, that's a conversion. I have to convert it to electricity, and then I have to store it, and then I have to put it into electric motor, and I have to store an electric motor somewhere, and I have to do a whole bunch of this work. Why don't I just dump it into the crank? I just need a CVT-ish kind of thing. It's like a clutch CVT thing. Like once it gets to a point where I'm running the serpentine and all the rest of the parasitic loss components, then it's like, Well, then I'll just dump it into the crank, and that's at those really high RPMs. Like, that starts creeping into that 15, and, like, I can start it at that 9, but at, like, 15, it's like, oh, I'm all day just making more and more power for my turbine right into my crank that goes right into my wheels. Uh, you know? And it's like, well, I got a nitrogen filter, so it's just always gonna send that nitrogen directly to my turbo, right? Uh, which is great. Effectively maintains it like a flywheel battery. So it's like, wee, 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 that kind of thing. Anyways, um, fun stuff for me after a while. And then it also turned into like, well, my fuel could go a hell of a lot longer, right? If I was in Formula One, because it's like, well, they have a fuel cap, they have a fuel limit cap, but it's like they don't say anything about oxygen. They don't say anything about oxygen, which means I have a lot higher amount of efficiency for my burn, which means I can actually push to a higher RPM and still maintain torque, especially if I burn it after. So it's like a little bit of fuel, and then I burn, and then I burn after. I then get more torque, and I still maintain my fuel limit cap, which is brilliant. And then it's like, yay, also right into my freaking crank. Give me more power. Give me that now. Give me that power. And then it's like, well, guess what? Exhaust. I need to cool you anyways because they can't be telling all the judges that you're running this nitrogen filter. And so I was like, behold the exhaust radiator generator. It's a piezoelectric radiator that is a little vacuum, Stirling thing. And so, like, the diaphragm moves and exchanges heat, because it's still got, like, surface area, like an intercooler. It just needs to maintain the heat profile. So it just needs to be surrounded by a given type of ceramic that's flexible enough. And then I get a bunch of electricity from the exhaust while I exchange it with the air, you know. And then it's like, no, no, no. Well, we had radiators here. We had all that. And it's fine. I don't. There's nothing going on weird here. I don't know what you're talking about. Not a, there's nothing. Literally nothing. Meanwhile, bzzz, bunches and bunches of electricity juice comes out cold, and it's like, no, 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 no. It came in hot. It came out exactly the same temperature as everyone else. I don't see what you're saying. Meanwhile, you look at it at the end of the straight, and it's like, it's a little cold, isn't it? Where did you get your thermal cameras from? You should have calibrated those correctly. There is no way that that's happening. Hey, I resent that, but I'm gonna check just in case. We need to reduce the amount of science here. We're gonna get this over for our engine coolant as well. We're trying to manage this a little better, okay? Because I also have my car radiator of the same type on my YouTube channel too. Because like I'm chasing all of the efficiency. I want literally all of that heat back as electricity and immediately back as power if I can do it. It's turned into linear acceleration, right? So like solenoids, but also into the crank itself styles of electric motors. So it's super, super compact. And it was like fucking poppet valves. And why the hell do I have this here? Which then turned into super turbo. I don't use. No, I'm not doing that. No. Meanwhile, the inside of the manifold of the supercharger type that I'm talking about is an actual like literal nitrogen filter. And it's like, no, it's not a super. It's new camshaft. Okay, and it doesn't do any of the compressions. Uh, kind of. It's really just really high flow rate, very high CFM. It's only getting compressed air from the compressor, which is the turbo. Okay? And that's all there is that's going on. Meanwhile, nitrogen, super turbo. I've got injectors that are rocket injectors. I've got rotating ring valves that go up into bottomers. I have anti-gyroscopic coming out. They're like, I need this 1 point, what is it, 6 liter inline four? World's best anti-gyroscopic inline four. Meanwhile, behold my new creation. But it didn't have the supercharger part on that. That came about later as I kept getting angrier and angrier about intake manifold problems. And I'm like, this is becoming annoying. Everything about this is pissing me off, actually. Eh. And then eventually turned into, behold, the supercharger camshaft, effectively. That is really what that actually is. But it's really high flow rate, and I actually do mean that because like I have to adhere to the rules. Like we can work within the rules and all that, but it's like the rules say it. I'm not allowed to have a supercharger, and it's like and it's not. It's actually still just a really high flow rate and a intake recycling. Okay, so like when it injects and then it sucks in and then it goes over to here really well, right? And the aerodynamic speak for airplanes is it re-energizes the air coming in, which effectively just means it flows easier. Okay, I'm not able to compress it. I could spin it as hard as I want, but I can't compress it. It still stays at a 1 atmosphere if I didn't have a compressor, right? But that also improves efficiency, which is the whole reason why I was doing it. Now, I would love to turn it into a compressor, you know I would, but I can't. So there's that problem. But I can get really good at making exceedingly low boundary layer effects and use vacuum effects effectively to skip it around and provide a very fast travel to the injectors, right? Which is really, really good. That's a big upgrade, okay? And then it was like, right, well, I have nitrogen in the bottomers, which helps cools the cylinder as well, right? On the up, you know, exhaust stroke, and then on the let's see here, what is it? Damn it. So the exhaust goes back into the bottom, and then that then gets yeeted out. Yep, exhausted into the turbo, right? The turbine, which I am tired. I've been up for a while. I was not meant to. I was not meaning, not meant, not meaning to record this, so you can hear it. But like that goes off into the turbine, but then during the intake it's like that's why it's going off, and then during the compression, it's then going to pull a little bit of a vacuum from crankcase or the valve crank things, anyways, that then go into the the bottomer area, and then I'm able to put in nitrogen from the filter. And so like that pulled a vacuum, and then now I have a higher degree of pressure. That pressure rise to air would normally you might want a vacuum because it'll help suck it back down, but of course you need a bigger flywheel for that, right? But it's like you don't want the flywheel because you'd want less weight. And so that means during combustion, that exhaust comes out and that goes off to the turbo. So that combustion stroke gives me the crankshaft rotation power, but it also gives me directly to my turbine, right, of my turbo. which is good because it goes directly now to the crank, right? And that pulses it. So every 180 then turns into a 90, which I was talking about earlier in one of my other earlier videos. But that's towards the end like this. Anyways, but that's great. And then I upgraded it because it's the hard materials and insulative material stuff. And it's like, that's literally what that was about for that. Besides like just making it super, super efficient, right? Because it's like, all right, so I do that, but then I am able to get a secondary torque pulse. So like a parasitic loss from that exhaust is now no longer there because that'll go back into the bottomer, which is sealed at, like a header, but it's a bottomer. Anyways, that's a whole thing. But that goes and it reduces parasitic loss. I don't get another power pulse from that. There's no power pulse, but I reduce parasitic loss as it goes back up. And that's actually a great thing because during the next power stroke for something else, I don't need nearly as big as a flywheel, and I don't need nearly as much power to sustain a given RPM. And the crank speed can rapidly increase. It actually has a problem right now for me of with the materials I have for ultra low friction and while it's not super super lightweight, but it's still fairly lightweight, I mean, those are all different types of materials. It's a coating, anyways. It's insulative and it's very hard, and so as a result, it's very low friction. But also, I use this like super fluid. Basically, I place this lubricant that's on the skirt that because I don't need piston rings. I then when I push it down through, it undergoes a phase transition. So it's a very low pressure environment, and then I pressurize it significantly, and it turns into a superfluid. But then it's, for the most part, under a vacuum around that, which is great. But that means it's really low friction. And then I do it for my bearings, for my main journals, and then I do it for my crank and all that. But it's also like, well, that's pretty much on all of the components that I use for my pivoting, then I use for my gearing and all the rest of it. And then that makes a very low friction, very rev happy, very, very scary engine that has an insanely high horsepower figure that would never work. Okay, like it would legitimately never work just because material strength doesn't work, right? Like there's a limit to material strength. I had to build like I'm starting to get into metamaterial designs, right? Specifically because I want to be able to get higher, like almost detonation velocities of piston speeds. But then I also get into like, what am I doing? Like I had this problem last time. I ended up at like freaking 10,000 C levels of freaking heat and pressures that made no sense because they were in the ocean, like deep below. I was like, this makes no sense. No, I'm not gonna go that far. But yeah, moving on. It's very rev happy now because of the bearing and all that. But like everything is more complex. Like I'm sacrificing com- uh, that type of lower complexity for more power and efficiency. That's just how it works. Like you kind of have to deal with it. Yeah. It's one of those big issues that we all kind of seem to face in engineering. I never seem to be able to get rid of it. Uh Rotating valves, great, but now I have fiddly little fucking gear bearings. which they'll last a really long time, but, like, they're a point of failure for sure. It's not a stick that's rotating, you know what I mean? So, and it slides, you know what I mean? Like, it's just what it is. But anyways, a lot of frictional losses that I wanted to try and overcome over a lot of that. But anyways, um, the reason I was talking about it is because it's like, well, now I have a solenoid linear acceleration and then a bunch of electric motors everywhere. And then I was like, behold, piezoelectrics. And oh, because it's so hot anyways, why don't I use thermoelectric and thermophotovoltaic generating materials in my engine block design? Because you're in Formula One and you're willing to pay for that amount of engine development. So, like, screw this, and I'm gonna chase 100% if I can of that engine's combustion to being turned into work energy if I could. Now, granted, it's not gonna do that. There's losses always. There's just always losses. But it's like I removed most of the friction. I have made it such that I get all of that back to direct work energy practically. And then, is there heat in the air? Give me that heat as extra electricity. Are you breaking? More electricity. More work energy. More. Are you vibrating that carbon fiber shell? What? Oh, piezoelectric it up. I'm making piezoelectric my bitch now. 90% efficient, so, like, might as well. Anyways, then it turned into, like, well, I'm at like 98% efficiency to work energy, which was not bad. But, like, that's because I'm factoring in captured air. Like, if I don't, then it's like I have a 10% loss of standard, like, copper or whatever in terms of, like, the cable and send electricity to somewhere, which then turns it into, if I look at it, it's really actually about 86, maybe 88%. It's in that range, right? And that kind of sucked after a while because I was like, behold, I need to get into all of these other ways of making different impedance matching and then acoustic, or, well, this is actually electromagnetic field, quantum momenta, resonant frequency, electron tunnel moments for electricity movement in copper lines. So I started learning about quantum physics specifically so I could make it still has resistance and impedance, right? So it's not a superconductor, but it acts like a superconductor using the resistance to its advantage. I still have to impedance match because otherwise you're fucked if you don't. You lose a lot of efficiency, but then it's like, behold, from 86 to 88, I'm at 90 fucking 7. Because it's like, that's the radiators, that's a lot of different, like, copper areas for, like, brush motors, right? But that's in the gears or whatever. Okay, then types of motor designs for repulse or attractive forces, and then it got to such a degree I was like, I'm gonna just try and, oh, whoopsie. All right, hi there. Yeah, no, we calibrated that correctly this time. Whoops, shit. Oh, did you? It's very cold, your exhaust. You know, I don't. What are you doing over there? So nothing's saying I can't have cold exhaust, by the way. No, but at the same time, the secret's up. The jig, the jig. Ah. All the advantages just get pooped out after a while, you know? So, usually you have to tone it down to about 76%, right? And that usually means you don't have it condensed so much that the the water vapor cools off in your exhaust manifold. I started using that though as a humidity uh style of electrical generation. Like there's a humidity, like they were like, "Oh, so humidity coming off of your clothes when you dry it can now become a generator, right?" And I was like, "Exhaust manifold go cooly cool burr. Resonant frequency of Bernie burn juices go nice with solenoid." Not even a joke. I started doing it and like it's dripping water. Where? I'm just gonna force more air from the radiators into that. Where? Meanwhile, it's well me 100 C at most. Oh yeah. Oh, okay, sure. Meanwhile, I'm looking at it. You have a heater. Yeah, a little. Just it's to fool them for a bit, truthfully. It's like, no. Tell me again why. What is this? This is about 5 degrees above ambient? What did you just say? Meanwhile, "Hey, hi, this exhaust is too cold. Come on, what are you doing over there?" Bzzz. Anyways, yeah, but that was pretty much like because I have a dream of like indie racing, anything for racing. Like I love engines, and no, I can't really maybe design an engine like that. I would love to. I mean, they're expensive as fuck, for some of those things. But like for the majority of the rest of it, I can usually piecemeal together something that currently right now I can make outperform basically everything else anyone else is doing. And I with a little bit of better engine tuning, from someone that knows something or whatever, I have a really good way of giving you an engine that's much smaller, much more compact, much more powerful, but also lighter weight, and it'll be reliable. But that also means you have to spend some money, right? But it's not going to be a $10 million damn engine or 100,000 or $200,000 engine, right? And instead, it's like, well, this is still a race engine. And it's like, yeah, oh yeah, it's gonna be fun. Uh, it's just most people tend to have a hard time controlling an engine like that, which is why it's like, these are race engines. Racing is what you're supposed to do with them. But I have a Toyota Corolla, or I have like this, you know, motorcycle. You know what I mean? Like, I can totally do that. Yeah. Like, I can do that. Nothing's saying I can't do this. I can absolutely and uh-oh. Is that crankshaft gonna work? Is it like, do you really want a super turbo where the camshaft's gone and it's just replaced with a supercharger? 'Cause I can do that. You can probably do it. And nitrogen, I mean, is your crankshaft gonna handle that? Is your transmission gonna handle that? Probably. Yeah, you're right. There's only one real way to find out. Let's go. No! It Meanwhile, doodle 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 doo. Let's brr. That's just who I am, though. But I don't have engines. I have an electric bike, and I have no income. and I'm trying to get an SSI and all the rest of it that goes along with that, right? And so like anybody that's like, man, why don't and it's like, because all of the reasons that that basically mean that there isn't really a way to do that, you know, and otherwise, you know, these are designs I think about because it's like, well, this stuff makes it so I think less bad killing me myself thoughts, which is not good. So that's good. Um, Anyways, yeah, naturally aspirated nitrogen filter energy tech. Little oversharey there at the end, but please like, subscribe, hit the bell, share. Have a good one. Bye. All right. I'm back. I did stop the recording. Um, so nitrogen that's coming in from the filter can be used into the exhaust port, kind of like a direct injector into the exhaust port, besides just going through with the stream of exhaust going out, and to help protect and cool the exhaust manifold and the catalytic converter, uh, which can help dramatically in terms of the heat problem of the exhaust port. Like most of it seems to work just fine. Especially if you're using iron, you only need to do like a little bit of work for coating if you even want to. But you do need to use a bunch more fuel than you think. Like a extraordinarily too rich mix, right? But then you burn after, but then that makes it act like a very leaned out mix that's extraordinarily hot. And then it gets shoved through your valve area and your exhaust port. And so it's like, oh, you probably would have been able to come up with this, but just as a little quick note, a little nitrogen just in there might help you out, right? I did use it temporarily as a quick fix until I just freaking coated it. Like I literally just coated it with like a ceramic, and I was finally done. I didn't have the issue anymore, but it does get extraordinarily hot for exhaust. Not so much for the intake, and the cylinder usually is good enough, but if you do a little bit of extra work, you can make that work. Um, there's also the elephant in the room that you might be able to get away with a type of cycle that allows for you to effectively just dump nitrogen into the intake and not do any actual injection and cool it off that way if you needed to. Right. All right. Yep. Bye.